All right, since I know you guys are all ready, go ahead, finish eating. You should know by now, Tater Tot, that every single time, you know that it's coming. It's coming. So be like, all right, I'm gonna wait. I don't want you to yell at me and like spit food again. That was kind of weird last time. All right, you ready?
Yes.
Okay, good. Denny, you ready? All right, class.
Yes.
Thank you very much. Now, just so you know, this class is more invigorated and louder than my couple of my other classes, which have 30 plus kids in it. Okay? So, yeah, does that say anything? Anyway, so yeah, my favorite class. That's why. You guys are my favorite right here. Big hug, big hug. Anyway, separable first order differential equation, slope fields, and Euler method. So we are only going to focus on the first two today, and with your calculator I'll show you the slope fields, and we'll show you mathematical what it means. Okay, see this right here? Okay, this is how it could be written. Equation, suppose this, which is a function given an x and a y. So before we would actually have like a y equals to give you an x value, and then you have like a coordinate to go with the y value, right? Okay, those things are we're one-to-one. But now we're going to be dealing with slope fields where you're going to have an x and a y, and they're going to be different as we go through here. So this is what it means. So if I'm going to separate this, it's a cross multiply over here. So that's going to turn this to multiply this way. So all my y's are on the left. This is going to go this way. So all the x's are on the right. So it's going to turn into remember the capital letters refer to like integration, right? So in terms of y, dy. Okay, that's the left. So I have an integration on the left-hand side. And it's equal to the m of x. So that's the integration in terms of x on the right side. So all my y's are on the left, all my x's are on the right. So that's what we're going to do. And then given that right there, I have a dy. Then over here I have a dx. I'm going to take care of those by taking the integration. Did you grab a note? They're right here. Okay, for examples. See this right here? So I don't know if you can see it. So x secant y. Okay. I want to get all my y's to the left, x's to the right. So what would I do to my dx to get it over here to the right-hand side? I'm going to multiply, right? So I'm going to multiply, so it's going to be a dx over here, because I'm going to multiply. And what about I got this right here, but right now this is being multiplied here. How do I undo my secant y? That's multiply. Divide both sides by secant y. So now it's going to look like this. So since I'm going to divide by secant y to both sides, this is going to be 1 over secant y dy is equal to x dx. Get rid of that one there. So that's what we're doing. That's by separation of this. But 1 over secant is the same as saying what? Secant is the reciprocal of what?
Cosine.
Cosine. So yes, I'm going to have cosine, right? That's going to just turn into cosine y dy is equal to x dx. There we go. So that's what it means to do. So all my y's are on my left, my x is on my right. Super easy, right? Does that make sense now? Okay. So going back to this one right here, same thing would happen for any of these. Any of these. Separable. Is that right? Separable? Anyway. All right, anyway, so we're going to now integrate both sides of the separate equation like this. So on the left side, as I take the integration of this in terms of dy, that means that my dy is going to go away as I do this. Over here, I have my x dx, so when I take my integration of my x in terms of x over here, my dx goes away. Holy cow. I was worried that you weren't still alive. All right, so now right here, let's go ahead and take this one, and I'm going to start by rewriting this. So if I put my x's on the right-hand side, so go ahead and do that. So x is on the right-hand side, y is on the left. Please do that. Make that happen. And we will see what you get. You got the notes, right? All right, do you remember the last set of notes you got? Yeah, oh, good. Yeah, you're good to go. You're not missing anything now. Need a pencil or something? You got one? Okay. All right, so now, let's see. Elizabeth, what'd you get? dy over y squared is equal to? Very good, 3x dx. Perfect. Okay, separation of variables. That is on my left-hand side. Okay. So find the general solution for this one. So now what that means is to get the general solution, I need to integrate both sides right there. So let's integrate that right there. And don't forget, the 1 over y squared is the same as saying y to the negative 2, right? So let's integrate that. Alyssa, you ready? You're like zoned out there for a second, so I'm just making sure that you...
Yeah.
Okay. All right, Danny, what do you get the left-hand side over here? Remember, you could rewrite it as y to the negative 2 dy. What do you do to your exponent? Add 1, and then you divide by that. So what would I end up with here? Divide by -1, very good. Okay, equals, okay, Alyssa, what do you get on the right-hand side?
3x squared over 2.
Now there's one thing missing here. One thing missing. Whenever I do these right here, what did I do on the last unit? What I kept adding to every single one of my integrations?
Plus c.
Plus c. But the problem is, we only need one plus c. Because we're going to have a plus c over here. There's going to be a plus c over here. There's going to be a plus c over here. But this is a constant, and this is also a constant. But then if I subtract this constant over here, I would have whatever this constant right here, look like that. So it'd be constant 2 minus constant 1, where I still get some constant, right? So I don't need to have two constants. So for all practical purposes, whenever I'm doing this this diffie-q type question, I only need 1 plus c. So I only need to put my plus c on the right-hand side. I like putting it on the right-hand side because, I don't know, I'm a weirdo. Okay? Plus c, there we go. Because I only need it one time. Now, I'm going to clean up this left-hand side a little bit. So if I clean up that left-hand side, what am I going to get there? 1 over, so it's a -1, right? Over y to the first, right? Equals my 3x squared over 2 plus c. So this is referred to as your general solution. A general solution has plus c in it because it is going to be something with some other constant somewhere. I get a constant. But now we're going to be doing is finding a particular solution. The particular solution is going to plug in x and y, so I will now know what c is going to be. Yep. Okay. So I'm going to plug in those values. So when I plug in the values, I'm going to get negative 1 over 2 equals 3, 1 squared over 2 plus c. So by plugging in all my variables, when I'm done, all that's going to be left is going to be my c value. Right? Okay. So this is going to give me a positive 3 over 2, and then I need to subtract 3 over 2 to both sides. So I have a negative 1/2 minus a 3 over 2, which is going to give me. Did I lose you, Alyssa? You gave me that crazy look again. Are you okay with this? 3 over 2.
Yeah, okay.
Okay, so 3 over 2, and I'm going to subtract it because I need to get rid of that, right? And if I subtract 3 over 2 to this side also, so I have a negative 3 over 2 and a negative 1 over 2 is going to give me a negative 4 over 2, right?
Okay.
And negative 4 over 2 gives me just?
2.
There we go. So negative 2 is equal to my c value. Now, this is the particular solution here. This gives me a c value, so this is a specific solution that goes along with when my function is this. So it is written as f of xy. So this is f of, dang it, come on now. F of my x and my y. So it's going to look like that. So we write it in this form. So instead of saying f of x, this says f of x and y. Now let's fill it in. So let's put it back into the equation, and that's going to give me f of 1 comma 2 is equal to my negative 1 over y equals 3x squared over 2, and that's going to be minus 2. Any questions on what we just did right there? Because we're going to do some rearranging here in a moment. All right, we're going to turn this into a standard form here. Standard form means it's equal to 0. Standard form equals 0. So what I'm going to do is I'm going to clear out my fractions. So clear out my fractions. So I'm going to change color so we see what we got here. So I'm going to multiply everything by the common denominator. What's my common denominator of the entirety? Y and 2, right? So common denominator for both of those is just 2y. So 2y times this over here times the left side is going to give me a negative 2 because the y's cancel. Equals, as I distribute over here now, there we go. Okay, over here now, 2's cancel, and I'm left with 3x squared y. And then over here, my last one over here is going to give me negative 4y. And again, my standard form is equal to 0. Standard form equals 0. So what do I do with that negative 2? Just add 2 to both sides, right? So I'm going to rewrite this as standard form it's going to be 3x squared y minus 4y plus 2 equals 0. Easy enough?
Yeah.
Okay. All right. Okay, so now what we got here, it says the first order differential equation of x and y, the function is continuous on its domain set of points where the xy plane at each x and y. So these are the ones for all the values of x and y in the domain of f. We can evaluate for those and determine right here what is my particular solution, the slope of the tangent line to the graph of the solution to the differential equation at a specific point. If we draw small line segments representing these tangent lines at every point of the domain of f, the resultant display is called a slope field. Gives a picture of the family of curves that make up the solution of the differential equation. So this is the general solution. This is the plus c. So we're going to graph with the plus c. You ready? So if I were to do this, use slope field to represent the solution of that. Okay. Let's use our calculator to understand what we're doing here. And then we're going to go backwards too. So I got my calculator already ready. Here we go, right here. Are you guys here?
Yeah.
In your car? At your house? Somewhere? Okay, then borrow one of those. All right, let's go to Scratchpad here. So we're going to the graphs. Make sure it turns on. Okay, so now we're here. We're going to go, once we're in Scratchpad for the graph, hit Menu, Graph Entry, and guess what type? What type are we doing? DiffEq, differential equations. That's what this is. This should be option, what is it? What option is it on yours? 8? Okay. I was just wondering because your guys' software is better than mine. Yeah, it's kind of weird. So the teacher software here needs to update. No one knows how to update anything here. So there is a major problem because of it. Anyway, so DiffEq. Now, our equation is y. So to show that this dy dx, it says right here, y, remember this tick mark, what does that tick mark mean?
Prime.
Y prime, which means the derivative, right? The dy dx, it means the same thing. So for this, every time you actually put y, anytime you put a y, you need to just say it's going to be y1, because that is the equation of this. So you put y 1. Make sense? Nonsense? Did you write down those steps or are you going to forget later? Yeah, okay. So it's gonna look like this. Okay, so I copied over my graph so we could actually talk about this now. So what this really says is that dy dx equals y. Now, if I do types of functions, let's go with, so f of, let's say, let me see, 1 and 1. Is that what my intervals are here? I think it's in half. I'm getting worried. 1, 2, 3, 4, 5. Okay, let's take this one right here. And so the coordinate there is going to be 0. I think that's 2. 2, 3, 4, 5, 6. Yeah. 2. I'm sorry. That's in the wrong spot. 0, 2. What's the slope of that going to be? If you're looking at it there, you look as I go, it's the same slope here, 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 here. They look like they're the same going all the way this way, right? Now, if I plug into this, do I have an x that I'm going to plug it into? Say no, because dx is not the same. dx means something else, okay? So, there is no x on the right-hand side, but there is a y. So, I plug in the y, what do I get? 2. So, what's the slope right here?
2.
My slope is 2, right? So, if you notice, as I keep going, so the x value doesn't matter. The y value is the only one that matters. So this is actually a note because you're going to have to do this later on yourself. So if you notice, since the x value doesn't matter, the y value is the slope. So whatever the y value is my slope because there is no x. So did you write that down? Because it's not in the notes per se in that language. So that's what you have. So if I'm going to give you a graph, you're going to tell me what the slope field is. You're going to have to understand that. Did you write that down? Or did you fall asleep again?
I'm trying to stay awake.
Not too many tater tots, that's what your problem is. Okay, so now we could actually look at each one of these. So if you notice, okay, let's try another one. Let's try where my y value is 0. So f of, let's go 2, 0. 1, 2, 0. What do you think the slope is right there?
0.
0. If you're looking at my graph, and if you notice, you could trace it out and look like it is going in that pattern, isn't it? It is going in that pattern.
Yes.
Okay, so did you write it down where I said, if there is no x, the y value is my slope? So the converse of that, would mean what? If there is no,
No. Y.
then there,
X is the slope.
x is a slope. If there's no y, then the x value is your slope. So what do you think that would look like? So if this is what it looks like this way, what do you think it would be if it was, I didn't have a y and I had an x?
It'd be just 0 for the first one.
Would it be the same thing right here? Would it look the same thing as this?
No.
No?
Okay. No. Let's see. Wait. if it's the same equation but it's equal to x.
Yeah, but what do you think the graph would look like?
Inverse, just invert it, I guess. What are you doing? I'm cursor.
I can't grab my.
Oh.
There you go. Trying to find it, get it to rotate.
I thought the other button was rotate.
And look at that, trying to be all fancy. There you go. So it would go like this, and my x values would be the slope. Going like that, wouldn't it? So it would look something like this. The x value would be the slope. Let's do it again.
Oh, it's pointing away from the y-axis.
Y value is the slope here, right?
Yeah.
Y value is the slope, so use, come on, come on. I want to line it back up. Come on. Hopefully that's it. Close enough. Now let's go back to the question here. So slope field represent that with my equation here. Use the slope field represent to draw some graphs of the family of solutions of that equation. Let's go back to the calculator, and hopefully this might actually make sense. So I gave a particular solution, hit tab, go back up, and now there's a little place right here where I could give a particular solution. That first one I gave you was what? 0, 2?
Yeah, it was 0, 2.
0, 2.
Okay.
There it is right there. So if you notice, that's what it is going to be with that particular solution. So the equation that would go along with this, that would fit the differential equation, goes through that point, and I have a line for that one now. And if I want to do a couple more, I hit tab, go back up to it, and let's add a couple different ones. Okay, give me some coordinates here.
1, 4.
Okay, 1, 4.
Yeah.
Any negatives?
-6, 5.
All right, let's see what those are going to look like. So going through -6, 5, way up here. Okay, if you notice right here, here's the other one. Okay, here's another particular solution. So doing particular solutions should be pretty easy. Let's go ahead and try let's change this one to a -2. Let's see what we have there for a negative in the y's. Okay, so it's actually following these lines, the slope field going down. So that's what it means. It just goes through there. Does that make sense?
Yeah.
Okay, good.
It just looks like
So we solved, we got a graph, we did a slope field for those. Which of the following differential equations could have the slope field shown below? Now, remember what I was telling you. I told you to write it down. Some people did not because they zoned out. What did I say about x and y? look carefully at this one right here. Now.
There's no y that x is slab there.
Okay, yeah. Okay, so that means what? So let's look carefully at this. Do they all have the same going this way?
Yeah, they're.
It looks like they're the same, all the same going that way, right? So what does not matter because of that?
Y.
The y doesn't matter, right?
Yeah.
The y doesn't matter because of that. So that means I'm going to get rid of part B. I'm going to get rid of D because both those have y's, right? Okay, so now what does this look like? If I was to put a single point in there, what shape would this give me?
Parabola.
This would give me a parabola, right? So doing my gang signs here. So parabola, is that opening up?
Yes.
Okay, so if it's concave up, what do I know about it? It has to be
Positive.
a positive, right? Concave up is going to be a positive, not a negative. So therefore, because of that, my answer has to be C. Is that pretty easy there?
Yeah.
So it went from super complicated to what the hell to not so bad.
Just too many lines.
Okay, yeah, it's a lot of lines. And sometimes you're going to have to figure out particular solutions where you have to deal with an X and a Y. And how would you go about that? Pick some points, right?
Yeah, pick a slope for you.
Yeah, there we go. Pick out some points. So from here, I would say, all right, if my X value is 0 and my Y value is 1, so let's see, my f of 0 comma 1 is going to equal what? What's the slope right there? 0. That's important. So when I do that, if I plug that in, 0, 1, does this one right here equal 1? Okay, so that one's not going to work out, is it? Okay, this one right here is going to be 0. Okay, hey, that one would work, right? That one would work. Okay, this one right here, plug it in. I would just get 0. That one would also work. This one right here, this is 0 minus 1. So my slope would be -1 there, right? By plugging in and using particular solutions, I can find what it's supposed to be. Easy enough? You're going to have to do some of these on the homework. But I am not going to get into those here today. Those are going to be tomorrow. I want you guys to finish up your, what was it, 5-6 from yesterday? Yeah, 5-6. Finish up the 5-6 homework. Did you already finish?
Oh, the one that was like due yesterday?
Yeah, the one that was due
That
yesterday.
was 500.